See, the first train went through, set it to red. These other ones are trying to push the next one through. Now the second one set it to red. You can see these two back here. The last one's trying to push the first one through. Now the third one exited and set it to red. Now we're essentially in an equilibrium mode for 4 trains. You can see.
Hello, I'm James Ingram. This video is digitized from a 1992 videotape series named V9202.
Using this block, there are basically 3 modes of operation that can be talked about. The first mode is what we'll refer to as depowered, where essentially the AC power is disconnected from the block and the block acts like a piece of straight track. The second mode is with 2 engines on the track, where one engine is definitely slower and one engine is definitely faster. In this situation, the simplest way to use the block is to put a magnet on the bottom of the slow engine, on the bottom of the fast engine to use no magnet. This is often the situation we find ourselves in at shows where we're running, say, a white pass and a mogul, or any 2 combinations of engines that have significantly different speeds. We're limited to 2 engines. Mode 3 is where you run 3 or more trains. In this case, all engines have magnets. This is essentially a juggling type operation where the block has got to juggle the trains to keep them separated. To do this, the trains have to run sort of the same speed in most cases, so you can't always achieve 3 or more trains. It just depends on the situation. I'm going to now demonstrate Mode 1 type of operation where the block is depowered, so it'll act like simply a piece of straight track. By opening this knife switch, which is normally closed, I'll just pull it up. It disconnects the power to the block. We want to make sure the arm on the rear of the block is pulled out away from the track to set the thing in the green state. Essentially, we make sure the block is in the green state, then we depower it. At that point, it completely acts like a piece of straight track. So I'll just run this engine over top of it, and you can see the engine has no effect. It doesn't close or open the block. Now let's turn the block on. Even though there's 1 train only on the track, we can observe that this train will begin opening and closing the block, that is, changing it from red to green. Now when this train goes through the block, when the engine passes over the track contact, we'll set the block to red. If there was a train following this train, that train following would have to stop. Now note when this engine goes over track contact T2, it'll change the block back to green. So the block can be operated with just 1 train on the track, even though it has no effect but simply to change it from red to green. You may or may not be able to see when the engine goes over this the track contact. Watch this little piece of paper I put on the arm of the rear switch motor. You can see it moves very slightly. That's moving the arm out and in. The arm is now out. When it passes over contact T1, it'll move in. manually set this thing to red. I manually changed that block to red just to show how it stopped that train. Now, normally another train would set it to green to make it take off. In this case, I'll manually set it to green. Now we're going to basically demonstrate what we referred to a minute ago as Mode 2 operation, where we have two engines on the track. One is faster and one is slower. In addition to the green engine, which has the magnet on it, I've now added in front of it a yellow work engine. The yellow work engine is significantly faster than the green engine, and therefore it will catch the green engine before very long. I'm going to initially turn the system on with the block in a depowered state, so everything will pass right through it as it's set now. What you'll see in about 3 or 4 laps around the circle, the yellow engine will come around and catch up with the green train and start pushing it. At that point, to demonstrate the operation of the block, I'll turn the block on and let the trains separate, and you'll see how the block will separate the two trains and then continue to keep them separated. See, the yellow engine's now caught the green engine. Let's turn the block on. Notice how the block is red and it stopped the faster engine, preventing it from overtaking the slower one. Now when the slow engine with the magnet gets track contact T2, it'll set the block back to green and this engine will proceed. Notice the fast engine has to wait every time around until the slow engine goes over track contact T2 and sets it to green. Thus what we're doing is giving the slow engine a head start. Basically the head start is equal from the distance at the end of the block all the way around the loop to track contact T2. In this case it looks like it's maybe about 20 or 30 feet of track. And this system will continue on operating this mode all day long if we so desired. Basically, the slow engine is controlling the block. The faster engine, without a magnet, has no control over the block. It is controlled by the block. Now we've got an even more mismatched situation as far as speed differences in the engines go. I've taken the green train off, I've left the yellow work engine on the layout, and I put on the LGB handcar, which you can see sitting over there on the edge of the camera. If any of you've seen an LGB handcar, you know they're extremely slow. So what we've got is a very slow handcar and a fairly fast engine, and we'll run those two and show how the block can still control the speed differences between these two units. You can see the handcar succeeds in making it through the block, crossing track contact T1 and setting it to red before the yellow work engine catches up to it. If you look real closely when the work engine passes the slowdown, the beginning of the slowdown block, which is right here where the 1015U is, it does slow down slightly. I've got the rheostat turned all the way up to 10 ohms. This engine runs so fast that it doesn't slow too noticeably in the slowdown block, not as much as a big train would, like a white pass diesel or something, but you can see it slow down slightly at this point from its normal speed in the rest of the track section. What we'll do now is move this track contact T2 just for illustration purposes. I'll move this thing closer to the beginning of the slowdown block, which will give the handcar an even greater head start. I'll do that right now. Here's the handcar we were running on the track a minute ago, and just to show how the magnet's been taped on the bottom of the engine. The handcar is not apparently made to snap the magnet on like most of the LGB engines, but we can put a magnet on this handcar by just taping it. The magnet goes from here up to here, and you just see I've just kind of put duct tape on the magnet to hold it on. We could also tape magnets on non-LGB engines using the same method of duct tape where they won't snap on. Such as like we taped them on REA engines or Kalamazoo engines successfully, and run those engines on the block systems. The slowdown block has been modified and track contact T2 has been moved. Track contact T2 has now been located back here, and the 1015U that defined the slowdown block has been moved up to here, and I've also moved the red indicator sign up here. What this does essentially is gives this slow engine even greater head start. You can see what will happen is if the block is set to red, it's green right now, let's manually put it in the red state. If this block is set to red, the slow engine will get all the way around to approximately here. It'll cross track contact T2, which will set the block to green, and that will set the that will allow the engine, the fast engine, to proceed. What this amounts to is the fast engine is getting almost a whole, the slow engine is getting almost a whole lap or a whole loop's head start on the fast engine. You can see all that this slow engine has to do nothing more than get from track contact T2 up across the block and past contact T1 so it can set the block back to red. It has to do no more than cover that small distance, and it'll be safe, so to speak, before it'll be caught by the fast engine. Let's just watch them operate in this mode. What you can see happens basically is the fast engine goes all the way around the loop, comes to the red block, and it's stopped, and basically just has to sit there and wait there until the slow engine, in this case the handcar, gets around to track contact T2, which is right in front of the red sign. This is a key point to notice with these block systems, is the way you can adjust the location of track contact T2 to accommodate a very wide difference in engine speed. So really on a show layout or display layout, you can have an extremely mismatched pair of engines with different speeds, such as the illustration used here with the handcar and the yellow work engine, and still operate a minimum of 2 trains on the block system, on each loop, that is to say. Now the next thing we'll do is try to demonstrate operating 3 trains on this loop. So I'm going to turn the camera off for a moment and reconfigure the layout with 3 trains. Now ready to demonstrate the third of our 3 modes of operation, mode 3 being 3 or more engines on the track, all 3 of them with magnets. What we've got lined up here is basically 3 trains. There's a green train in front and a blue train followed by a red train. They're all kind of stacked together, so to speak, at the moment. What I'll do is run them around, and you can watch the block separate them. And once the block separates them, we'll keep them separated, and these trains should run on the track, not catching each other. Notice the slowdown block has been moved back to its original position. The slowdown block now starts here, as indicated by the red sign. Track contact T2 has been moved over here, indicated by the green sign. I remember to move it this time, and here's track contact T2 right in front of it. So whenever an engine leaves the block, it'll leave the block back there, travel around up along the wall, which is just out of the camera. It'll come back in and go over T2, and when it gets to this point, it'll release, so to speak, the engine sitting at the block. So you're defining a spacing, in this case, from here back to that block, whatever that distance is. That's the spacing that will be defined between trains as they exit the block. I had to shorten the spacing to get 3 trains to operate. If I left track contact T2 over here, where it was originally, the 3rd train would catch the 2nd one before the 1st train ever got around to release it. So that's why we had to move track contact T2 back towards the block to get a shorter space in between trains, so we could run 3 of them on the loop. Notice the first engine that went through set the block to red, so these engines here are just stopped until the first train gets over to track contact T2. Notice the 2nd train went through, changed the block to red, so it stopped the 3rd train. Now this train will be released when the blue train goes over track contact T2. There it goes. Now we're essentially operating an equilibrium mode of operation where the trains should stay separated. Notice you can now see the effect of the slowdown section as those trains cross in front of the red sign that says slow and enter the slowdown section. I think you can notice they're coming in here a little bit slower. I've also adjusted the forward rheostat, which adjusts the voltage in the on-off section. It's very subtle. It may not be real apparent from the angle the camera is set at, but when they stop and then start up, they're starting up at actually a slightly reduced voltage, and then when they hit the main part of the track back here, they take off at full voltage. Watch this engine. It starts up a little bit slower and then goes to full voltage once it gets over here. This is just done. This forward rheostat is really kind of a minor enhancement. It just gives them a reduced starting voltage so they don't yank on the cars quite so hard when they start up as the block changes from red to green. don't know if it's apparent or not on the soundtrack. I tried to put the microphone next to the green engine, but from where I'm sitting, you can hear it start up at a reduced speed as that green train leaves the block, and then when it hits the main part of the track, it goes back to full volume of chuffing. We've now modified the system again. We've added a fourth train to the loop. So what we've got parked here, basically starting with the green train and working back, we've got a green train, a blue train, a red train, and another red train. So we've got 4 trains on this system right now. The slowdown block is essentially as before, unchanged. What I have done, I moved a track contact T2, which a minute ago was here. I moved it back here. What this essentially does is defines a shorter spacing between trains. I tried it with the track contact up here. What happened was it took too long for the trains to set it to green. They started catching each other over at the block. So by shortening the spacing, they release earlier. This is basically the adjustment you make on a display layout as you add more trains. As you keep adding trains, you've got to keep shortening the distance between trains by moving the track contact T2 back closer and closer to the block to get an earlier release so that the trains don't catch each other and start backing up at the block. And when you reach the point that you've moved track contact T2 back to the block so close that they can't maintain their spacing all the way around the loop, you've essentially reached the limit for those particular given trains of how many you can put on the track. So basically you just try moving track contact T2 back closer and closer to the block as you put more trains on, and try to keep them separated or hope they'll stay separated. As you can see, or as you might expect, the shorter the separation distance, eventually they just won't stay separated all the way around the loop. Let's demonstrate this in operation. See, the first train went through, set it to red. These other ones are trying to push the next one through. Now the second one set it to red. You can see these 2 back here. The last one's trying to push the first one through. Now the third one exited and set it to red. Now we're essentially in an equilibrium mode for 4 trains. You can see these 4 trains will operate on the track and stay reasonably well spaced. Notice the effect of the slowdown block. Some of the trains make it like completely up through the slowdown block and they stop, like this blue one. Others actually are delayed enough in the slowdown block that they never have to completely stop, or they stop only for an instant. This one just stops for a second. Notice that red one that's in the slowdown block now the block will go to green before it completely stops. So notice this train didn't have to even make a complete stop. Likewise, the green one that's coming in the slowdown block now, I don't believe it'll make a complete stop. Notice this train here will start up before it stops completely. So the slowdown block basically slows trains down as they approach a red block. In some cases, the block goes green before the train gets to the on-off section. The train will never stop at all. Or in the case where it has to stop, the slowdown block slows it down before it comes to a complete stop. Now got the same 4 trains on the track as before. The one change we've made is to remove the 1015U section here. This 1015U was right in this track section. I've removed this 1015U and replaced it with a standard 1015, which is just a 6-inch piece of straight track with no gap. What this does effectively is remove the slowdown block, because what was the slowdown block is no longer electrically isolated from the rest of the loop, which is out here. So now the main loop comes all the way around here, and it goes up to the back of the block. The main loop comes up to the back of the block, which is here. These blocks can be built without a slowdown block, that is without using the rheostats or a resistor. Just to demonstrate how they act without a slowdown block is why I've removed that 1015U back there and just using a piece of straight track. So we're going to now run this block, and it will behave the same as if it were built without using the rheostats. You can see the trains will still say separated. There just won't be any slowing down in the slowdown block, or what used to be the slowdown block. They'll come up right up to the block at their full operating speed and then make a hard jerky stop, which it works fine functionally. It's just not as nice to watch. The slowdown block makes the layout a lot smoother in operation. I notice this blue train, it's going to get up to the block, and notice it'll make a jerky stop, then it takes off again. So there's no slowing down without the slowdown block. They just make a hard stop. This one did the same thing. It just made a hard stop. So what the slowdown block does, essentially, it's a refinement that makes the thing operate more smoothly. You're slowing trains down, in many cases slowing them down without completely stopping them, rather than stopping them with a jerk and then starting them back up. But as I mentioned earlier, you can build a block without any of the rheostats or without a resistor and have just a simple on-off block. All we're really operating here just now is essentially the on-off section, which is this part of the block. Just a final parting comment to make on hardware in the form of couplers. Actually, these German prototype engines with the loop-type couplers are about the easiest to use for automatic block-type operation. You can see I've been able to push my trains one against the other. Normally you can't get away with this, but with short trains, like I've been using here to demonstrate in the loop couplers with the German engines, you can get away with more than normal. These can, if this is the beginning of one train, this is the end of the last train, you can actually push fairly hard one train against the back of the other train with these loop couplers and the buffers and not derail. The loop couplers also seem to stay together better than the knuckle couplers for starting and stopping with the block. So if you've got European prototype trains and you've got loop couplers, they're actually probably better to use than the American trains with the knuckle couplers. Notice if I put this American engine on here with the cow catcher, if I push against that car now, what it tends to do is when they push against each other, that cow catcher will actually derail that car, and as soon as it hits a curve, it'll push that car off the track. And that's why I purposely didn't use one of these engines with the cow catchers for the demonstration. I used the German engines with the loop couplers, which are superior for bumping against each other. Now, if your blocks are operating properly, your trains will always be spaced, and this won't be a problem. But invariably during an 8-hour-a-day or 12-hour-a-day show, something will come derailed, or something will decide to slow down, or something weird will happen, and for one unexplained reason or another, you will get one train bumping into another temporarily till you find what the problem was. And with the German engines and German couplers, loop couplers, you can get away with that happening with less chance of a derailment. That's just a point I wanted to mention.